Hey friends, I am Afrasyab and today I am going to teach you glycolysis. First we need to look out does it mean. Well, it is a process which is the degradation of glucose molecule uh, in which it will finally generate a molecule which is pyruvate. By its naming, glycolysis is of Greek origin. Glykos means sweet in taste and lysis means splitting. So molecules, glucose is involved and the splitting process takes place. Sometime an MCQ came, that is which step is common between both type of respiration, like aerobic and anaerobic. So you can take out glycolysis. Before proceeding further, we need to discuss history of glycolysis. Well, in 1930s, there are a German biochemist, the name Gustav Emil Otto Meyerhof and Jacob Prinz, that has determined that glycolysis is completed in 10 steps. So I will teach you 10 basic steps of glycolysis. Each step is catalyzed by different enzyme. Glycolysis takes place in cytoplasm, while Krebs cycle and electron transport chains takes place in mitochondria. So glycolysis is the cytoplasm while mitochondria in Krebs cycle. Krebs cycle and electron transport chains are inside the mitochondria. This is the overview of glycolysis, in which we can say that the concept of glycolysis can be understood. Here is a glucose molecule and it need to be conversion into two pyruvate or pyruvic acids. Glucose is a 6-carbon compound and it needs to be converted to pyruvate, which is 3-carbon compound. During the first step, I mean the glycolysis, it will yield the 2 ATP molecules. This pyruvic acid is further goes in citric acid cycle, which is also called as Krebs cycle, and at the end it will yield that the oxidative phosphorylation, which is electron transport chain. Here the number 2 indicates that the two pyruvate molecules are formed when a glycolysis is completed, and the result is ultimately the product of glycolysis is 2 ATP. Okay, here we go. Now the steps of glycolysis. We have step first. Glycolysis is completed in 10 steps, and the first step involved in the phosphorylation of glucose. Glucose is phosphorylated into glucose 6-phosphate. In the presence of enzyme, we call it hexokinase. Here we need ATP molecule to produce ADP molecule. One phosphate group is attached to glucose molecules, and you can see that this phosphate is attached to carbon number 6 of the glucose. Carbon number 1, 2, 3, 4, 5 and carbon 6. So carbon 6, at carbon 6 position, glucose molecules contain phosphate group. In step 2, here we have isomerization of glucose 6-phosphate into fructose 6-phosphate. Just we need an enzyme, phosphoglucoisomerase. These enzymes helps in isomerization of glucose 6-phosphate into fructose 6-phosphate. In step 3, again phosphorylation need. We need another molecule of ATP. It will convert into ADP molecule, and the enzyme required phosphofructokinase. Hence fructose 6-phosphate is phosphorylated into fructose 1,6 biphosphate. You can see at carbon number 1 and carbon number 6 phosphate groups are attached. In step 4 and step 5, now the cleavage of fructose 1,6 biphosphate takes place into two molecules. One is glyceraldehyde 3-phosphate and another is dihydroxyacetone phosphate. Dihydroxyacetone phosphate is the isomer of glyceraldehyde 3-phosphate. So an enzyme which is called as isomerase, it will convert dihydroxyacetone phosphate into glyceraldehyde 3 molecules. Here X2 means 2 molecule of glyceraldehyde 3-phosphate. The cleavage in step 4 takes place by aldolase. In step 6, glyceraldehyde molecule is again oxidized by using NADH2. Here we have 2 molecule of glyceraldehyde 3-phosphate. We also required 2-phosphate which is inorganic. Here it is not written, so add it please, 2-phosphate here. So by using 2-phosphate we can say that is again it will phosphorylate and it oxidize. So by oxidation NADH2 is formed. 2 hydrogen will remove from glyceraldehyde 3-phosphate molecule, and this will catalyzed by enzyme glyceraldehyde 3-phosphate dehydrogenase. Here you can see that is an unstable bond between the phosphate molecule and carbon number 1 of the glyceraldehyde 3-phosphate. 1,3-biphosphate is actually glyceraldehyde 3-phosphate will result into next step. Here you can see that the bond which is unstable, it will further it will break out by using ADP molecule, and 2 molecules of ADP will added into result to ATP forms, then phosphoglycerokinase, and the bond will break out, result into 3-phosphoglycerate. ATP will be formed. This method of ATP production is known as substrate level phosphorylation. So remember, during glycolysis, substrate level of phosphorylations takes place and result into the ATP formation. Next one, in step 8 we have the molecule which is left over 2 molecule of glyceraldehyde 3-phosphate by using enzyme mutase, phosphoglyceromutase. This will actually mutase, or this will just dislocate this phosphate group into carbon number 2. You can see that here the carbon number 2 phosphate group is dislocated. In next step, step 9, a water molecule is released and it will result into the phosphoenol pyruvate. This is also called as PEP, and result into the unstable bond is formed between the phosphate group and carbon number 2 of the phosphoenol pyruvate. And next step, we required ADP molecule, and this will release into 2 molecule of ATP. In step 10, again we need pyruvate kinase enzyme and the 2 molecule of ADP, which will lead to formation of 2 ATP molecule, and this bond will break out, phosphate is added, and result we have ATP and pyruvate molecules. There are 2 molecules of pyruvates are formed and 2 ATPs are released. That's all about it. Thank you. If you want to see our future videos, you can subscribe and share with your friends, colleagues. Thank you.